Okay. Hello. So we'll make sure, yep, we're recording, we're sharing, we're good. Okay, so this is our second video for the lecture covering for unit analysis, unit dimensions. You know, it's cold outside, so I'm freezing. It's 5 degrees. Oh my gosh. All right, so let's talk about the metric system. You will have already seen my lecture on this, and this is just to help to support you in your notes and understanding. The basic units in the metric system are for length. It is, let's hope my pen doesn't freak out on me today. There we go. For length, it is meters. And of course, there it goes. Meters. That's about as long as a yardstick. The weight or mass is gram. And that weighs about as much as a paperclip. Capacity is liter. And about the capacity of, I'm trying to remember what we did for this. I don't have my notes with me in front of me. Cannot for the life of me remember what we did for the capacity. Oh, I know what it was. It's about the size of a quart, or 2 pints or 4 cups. So we did a quart for that one. Sorry for the relapse in memory. All right. What's next? What is the difference between mass and weight? Okay, well, if you remember, weight, we talked about in class, is weight is equal to mass. And mass is what someone mentioned, the amount of space something takes up. And I like the way they put that. But weight is the mass times gravity. So times gravity. Mass, however, does not take into consideration, or does not have, take into consideration. You don't have to write all this. It's just to discuss it. The gravitational pull of the Earth. Gravitational pull of the Earth. All right. So weight is actually made up of the mass times the gravity that's holding us here. All right, mass does not have that, and it's what it is. All right, example 8, let's talk about that. Convert 7,225 centimeters to meters. So if you look at your useful conversions, you will see that there are 100 centimeters in a meter, 100 centimeters in 1 meter, and that's what we're going to use. So now we start with what they give us. They give us 7,225 centimeters. We're going to meters, so just one conversion. Centimeters is currently in the numerator, so we need centimeters in the denominator, meters in the numerator. Now we can plug our numbers in. All right, multiplying straight across. When you do that, the centimeters are gone, okay? And then you do this. 7,225 times 1 is just 7,225 divided by the 100. Now, you can use a calculator, or if you use the little, if you understand how to do the whoop-de-whoops to move forwards and backwards, knock yourselves out. If you are not from this country, you should already have this down like the back of your hand. If there's anyone who is struggling at all with any of this, please let me know, whether you're from the country or not. So 7,225 in the calculator divided by 100 is 72.25 meters. All right. So in our sentence form, 72.25 meters is equal to, you can do that too, equal to 7,225 centimeters. And there's my sentence. All right, moving on. Example 9. In the Summer Olympic Games, athletes compete in races in the following lengths: And I remember with this one, Nat's crazy enough to run the whole darn thing. So we're going to add up the 100, 200, 400, 800, 1500, 5,000, and the 10,000 to see how many meters she ran in total. So 100 meters plus 200 meters plus 400 meters plus 800 meters plus 1,500 meters plus 5,000 meters. You're going to make it plus 10,000 meters. So when you add all those up on the calculator, you get 18,000 meters. All right. Now we need to know how many, how the conversion works moving to kilometers. So if you look at your useful conversions, right at the top of the metric of the middle of the page, right at the top under length, I've got a conversion that shows you that there's 1,000 meters in 1 kilometer. So 1,000 meters is equal to 1 kilometer. So we can convert pretty easily from meters to kilometers. Meters is currently in the numerator, so we need meters in the denominator, so it goes away, and kilometers in the numerator. All right, plug in the numbers. 2, 3, multiplying straight across. Meters are gone, and we get 18,000, 2, 3 kilometers over 1,000. And if you punch that into the calculator, you're going to get 18 kilometers. All right, so how many kilometers will she run? Nat will run, or Nat ran, however you want to say it, ran 18 kilometers. There you go. Example 10, one bottle holds 295 deciliters. If it was decaliters, it would be a DA. So if you look at the second, flip the page over, you'll see on the conversion chart, there's deca and deci. Deci just has a D, deca has a DA. So here in a little bit, you'll see DAG, DAG, that's decagrams, okay? So I've already had some messages on the homework about that. Only one of my classes has actually gone through that part. Okay, one bottle holds 295 deciliters, while another holds 28,000 milliliters. What is the difference in capacity between the bottles? Now, if you're finding the difference in anything, you're going to be subtracting, okay, to find the difference. But before we can do that, we can't do anything when the units are two different units. They have to be the same unit before we can compare them, or subtract them or add them. So first thing we're going to do is move them to the same unit. And I believe in all my classes so far, we've chosen liters. So I'm going to stick with that for everyone. Should have pulled my chart here, but I think we're good. I think there's 10 deciliters is equal to 1 liter. Stinker. My hand does that sometimes. All right. And then there are 1,000 milliliters in 1 liter. Okay. So let's just do some converting. We're given 295 deciliters. And converting that, we want deciliters in the denominator and liters in the numerator. Put our numbers in, multiplying straight across, the deciliters are gone. And we end up with 295 divided by 10, and this is liters. Punching it into your trusty calculator, and you get 29.5 liters. All right, let's look at the second one. 28,000, 1, 2, 3 milliliters. In that conversion, it's going to have milliliters in the denominator and liters in the numerator. 1,000 milliliters equal to a liter, multiplying straight across. Milliliters is gone. And you get 28,000 times 1, so 28,000 divided by 1,000 is equal to 28 liters. Okay, now we can compare them. We can find what the difference in capacity between the bottles is just by subtracting the 29.5 and the 28. So 29.5 liters minus 28 liters is 1.5 liters. So I would say the bottle that holds 295 deciliters is 1.5 liters larger than the one that holds 28,000 milliliters. Okay. So the 295 deciliter bottle holds 1.5 liters more than the 28,000 milliliter bottle. All right. Sorry, this pen is just, and I've changed tips and everything. It's just not fun. All right, let's go to the next one. Example 11. A 2-liter bottle contains 87 centiliters. So we've got 87 centiliters of oil and 4.1 deciliters of water. Okay. How much more liquid is needed to fill the bottle? All right. So we've all seen a 2-liter bottle. If you go to any convenience store or grocery, we've got 1 liter, 2 liter, and 3 liter bottles. The 2 liter is what people typically are purchasing. All right. So if we have a bottle, and do not laugh at me because I am not a, all right, that's really bad, but at this point, I don't care. We've got 87 centiliters of oil. So let's just say that this section right in here is, well, we'd have our water on the bottom, wouldn't we? But okay, we'll just say that that's our oil, and it's taking up 87 centiliters. All right, let me see if I can change colors for the, yeah, we could do blue. Let's do blue for our water because we got 4.1 deciliters of water. So we'll say that this is our water in here. I know that's so pretty. So that's our water, our H2O, and that's taking up 4.1 deciliters of the bottle. But we know the entire bottle is 2 liters. So I'm going to go just to a different color and stay with that. So this whole bottle here is 2 liters. All right, so we need to find out, because we can't subtract or add or anything. What are we going to do here? We're going to know we're going to have to do some conversions, but to do what? Well, we've got a 2-liter bottle, and part of it is 87 centiliters. Another part of it's 4.1 deciliters. We need to be able to add those two things together to find out how much space they're taking up in that bottle, so that we can find out what the difference is in the part that can still be filled up. So we're going to have to be able to add those, the deciliter and the centiliter, the oil and the water. But once we do that, we need to find out that space, and to find out that space, we need to take those numbers that we've added and subtract them from our 2-liter bottle, because if you've got a bottle and it's got this much in it, to find out the difference, you're going to have to subtract. Okay, so let's do that. It's a 2-liter bottle. And I know in a couple of my classes, we decided to move to liters in that. So let's do that. So let's see what's our conversions. Our conversions are centiliters. So centiliters, there's 100 centiliters in 1 liter, and there are 10 deciliters in 1 liter. All right, let's go with what they're giving us. 87 centiliters times, all right, centiliters goes in the denominator, liters in the numerator, 1 and 100. That gives us 87 divided by 100. Oh, this is liters. So that's 0.87 liters. All right, the next one is 4.1 deciliters. So that's going to be deciliters down here, liters in the numerator. 1 liter is 10 deciliters. Multiplying straight across, deciliters is gone. 4.1 times 1 is 4.1, divided by 10 liters is 0.41 liters when you plug that into a calculator. Okay, we've got the oil, we've got the water. To find out what they are together, we have to add them. Where's my little pen thing? There it is. We have to add those two numbers. And when we do that, we get, that's an 8 and that's a 1.2. So the oil and water together fill up 1.28 liters. So we're going to need to take that number that they're filling up and subtract it from the fact that we have a 2-liter bottle. Okay, so 2 liters minus the 1.28 liters. What do we get on that? I think it's 0.72 or something. 2 minus 1.28. Yeah, 0.72. All right. So we end up, that space that can still be filled in, get in here and write, is 0.72 liters. All right, so the question was, how much more liquid is needed to fill the bottle? Well, there needs to be you don't have to write all this. I'm thinking, okay, there can be 0.72 liters to fill the bottle. I was thinking of there needs to be 0.72 liters to fill the bottle. Liters of liquid or liters, whatever. There needs to be 0.72. Oh gosh, that is a 7, 2 liters to fill. I don't think my eraser is working now. Hold on, y'all. I'm gonna make it a little bit nicer. Eraser. Or try to, anyways. Okay. 0.72 liters to fill the bottle. You can even say 2-liter bottle. There you go. All right, moving on. Example 12, Pat, a boxer. Okay, if you are in my night class, my Wednesday, oh wait, you already know now. We already talked about it. This is the one that we got wrong in class and we fixed. So if you didn't get it fixed in class, or you got confused because, oh my gosh, we did it wrong, and then we went back and did it right. Sometimes people their minds have trouble shifting from one to the next. So I want to make sure that if I lost anyone, since we were, right at that cusp of time, if I lost anyone, I want you to make sure that you get a good understanding of it when I'm done now. All right. So Pat, a boxer, weighs in at 85 kilograms. All right. He is 80 decagrams heavier than his opponent, Job. How much does Job weigh? Okay, so Pat's the one that weighs 85 kilograms. He weighs more than Job. He weighs 80 decagrams more than Job. So in order to find out how much Job weighs, we have to subtract those 80 decagrams from Pat's weight. And because weight is given in 85 kilograms, and they're asking for Job's weight, you're gonna wanna represent it in kilograms. So the goal here is to have everything in kilograms so that we can subtract, okay? If that's the case, the only thing we need to convert is decagrams. And if you're looking at your useful conversion chart, you'll see that what we did in class, we went from decagrams to grams, because we know that there are 10 grams in a decagram. And then we went from grams to kilogram, because we know there's 1,000 grams in a kilogram. So let's write down our conversions and then use them. So there's 10 grams in 1 decagram, DAG. There's the DAG that you're going to see in your homework. And there are 1,000 grams in 1 kilogram. Okay. So now we can take the 80 decagrams that Pat is heavier with and convert. All right, so that's 80 decagrams. So that's DAG. We're going to do 2 conversions here. We need DAG at the denominator, the decagrams, and then we'll have grams in the numerator. Then we're going to get rid of the grams and move to kilograms so that we can have the answer in kilograms. All right, there are 10 grams in 1 decagram. There are 1,000 grams in 1 kilogram. All right, we can multiply straight across now. The decagrams are gone, the grams are gone, and we end up multiplying left to right. 80 times 10 times 1, which is 800, divided by 1 times 1,000 is 1,000. And this is kilograms. So punching that into your calculator, you're going to get 0.8 kilograms. Okay. Pat's the heavier one, so we're going to subtract the 0.8 kilograms from Pat's weight, okay, to find out what job is. All right, so we've got 85 kilograms minus the 0.8 kilograms, and we get 84.2 kilograms. So Job weighs 84.2 kilograms. Okay, and there's your sentence. All right, at this point, you're going to complete the UTRI 2.4. We will already discuss this in class. So if we've already covered this section in class, you need to bring your 2.4 to class. If you don't make it to class on the day that we cover the UTRI that you did, I will be making a video for the entire group of UTRIs. So that will be the last video I make, not tonight. All right, I'm gonna stop this video and we will move on to, I'll make this one your next one. So stop recording.